Right, final lesson in this Moments chapter is all about tilting, and it's very simple really. If we're on the point of tilting, so if I imagine if we're on the point of tilting around this blue pen, well, let me demonstrate first what it is to tilt around the blue pen, right? If I tilt around the blue pen, it means that I've come up, so this has come down here, this part's come up, and it's no longer in contact with the purple pen, right? It's elevated off the pink pen, sorry. Right, so that's what tilting around the blue pen would look like. Now, obviously, this will be able to tolerate a certain amount of weight before it does tilt, but then when the force gets too much, it will come up. Now, if it's on the point of tilting about C, what that means is that it's almost ready to go. So it's resting, it's still positioned as if it's on the pink pen, but if you almost imagine it's like the tiniest fraction above the pink pen, ready to tip. So it's not tipped quite yet, it's there, but the key point would be it's putting no longer any pressure on the pink pen. It's either touching it just but with no pressure, or you can imagine it as it's just the smallest fraction of a centimetre or smallest fraction of a millimetre above the pink pen, so it's not touching. What does that mean in reality? It means the reaction at the pink pen should be modelled as 0. So if we're on the point of tilting around the blue pen, it means that there is no longer any reaction force on the pink pen. Everything will still be in equilibrium. It's not moving yet when it's on the point of tilting. It just means that we're doing an equilibrium model and there's going to be no reaction on the pink pen. So let's have a look at that in example 11. I've got a diagram. It tells you it's uniform again, so we can go back to modelling it with the weight in the middle. And we've got two supports, and it tells you that when the child stands at A, the beam is on the point of tilting about C. So if it's on the point of tilting about C, that means that there is a reaction force at C still, but there is no reaction force at D. So I'll put a cross there to show you that's because it's at the point of tilting about C. Other than that, it's exactly the same as all the other problems. So label up all my forces. I've got my child. We don't know the mass, so we've got the child of mass m, mg standing there, right? And we've got the uniform beam of mass 45 kilograms. So it's a 16 meter beam. So it's going to put the mass about here, because it's 8 from A and 8 from B. So that's 45g. And I'll just fill in here that this is going to be 3 meters. Okay, so 45g at the middle, mg where the child stood, reaction at C, but absolutely nothing going on at D. Again, what are the options for these questions? Always the same two options, right? We can resolve it vertically, which I'll demonstrate here. We'll have that R is equal to mg plus 45g. Not much use there. We don't know R, we don't know M, so unless we get more information, we can't find that force. The other thing to do is to take moments. Moments about, and last few examples I've taken moments about A. That's not really a great idea here, because if you think about it, that would then eliminate, there'd be no mg in my equation. I need to find M. If you did do moments about A though, that would allow you to just have an equation with R and 45g in, so you could find R, then you could use the first bit, if you knew what R is, to find M, right? Or, if I take moments about C, about the point of tilting, it's going to be a little bit easier, because then we've only got two forces. The R will be eliminated, and we'll have mg and 45g. So, what do we need to do? We need to think about if this is the pivot point here, when we tilt. So if we tilt downwards, if this is moving it down, again, imagine it, there's the point, tilt down, that's a clockwise movement, but with the child on this side, that force will be a anti-clockwise movement. So let's do the anti-clockwise first. So the anti-clockwise is the mg going down here, and the distance from the pivot is 5. So it's 5 mg is the anti-clockwise direction. On the other hand, the 45g is being multiplied by 3 because the distance is 3. 3 times 45g which is 135 g in the clockwise direction. We know, even though it's on the point of tilting, it's not yet moving, which means it's in equilibrium. Right? So it's still modelled like it's in equilibrium. That means that this and this are going to have to be equal. But there's no reaction at D because it was on the point of tilting. So 5 mg equals 135 g. G's are going to cancel and you'll get m equals 135 over 5, which is going to give you 27 kilograms. So our child weighs 27 kilograms. Well, no, he doesn't weigh it, sorry, his mass is 27 kilograms.